All right, so as we finish up these last 4 trig derivatives, I gave you kind of a hint about it yesterday. I told you something that you already know about these 2 derivatives. Do you remember what I said? Okay, those are going to be negative. Just like cosine has a negative value, cotangent and cosecant also have negative values. And there's definitely patterns to how these go. So although you're learning 4, I really feel like you're only learning 2 because the others, they're so similar that hopefully you have brain space for those. We went through all of Newton's proofs yesterday for sine and cosine. That's all you need. You don't need Newton to prove any of the others because once you've proved sine and cosine, the rest of them follow naturally. So you're not going to have to worry about that. All right, the derivative of tangent. I'm just going to tell you right now I'm going to tell you what the 4 are, and then I'm going to show you how we come up with those derivatives. The derivative for tangent is secant squared. Okay, I'll show you why it is, but I'm just going to tell you what it is right now. Okay, the derivative for cotangent has to be a negative, and it is similar. If tangent matches up with secant squared, then cotangent matches up with cosecant squared. So those 2 things, one of them is secant squared, one of them is cosecant squared. So the goes with the cotangent goes with cosecant squared, and it has a negative as its sign. All right, now we'll get to the derivative of secant. The derivative of secant is positive again. Its derivative is secant times tangent, and we'll show you why in just a moment. But secant x times tangent x. One thing I am kind of picky about for this is that you put an x for both of them. Sometimes I'll see sloppy students write secant times tangent like that, and maybe they'll remember an x by the tan, but they forget the x by the secant. Both of those are separate functions, and they each have their own x value, so please make sure that you don't write it that way, that you include x for both of them. All right, so now that you kind of see the pattern, does anybody want to take a guess, an educated guess at what they think the derivative of cosecant might be? Okay, Sean? Close. It is negative. Okay. It's a multiplication, just like the other one is. Andre?
Negative cosecant x times cotangent.
It is. Yep, there you go. Okay, it's the co for both of them. So the derivative of cosecant x is negative cosecant x times cotangent x. So now you know all 6 trig derivatives, and I'll show you why those are on the next slide. Any questions so far? Okay. All right. Now you're going, wait a minute, you said we weren't going to have to prove these. I said we weren't going to have to prove them using Newton. Okay, but there is a way to prove it using trig identities. All right, so here's the proof for tangent. All you got to know is what the trig identity is for tangent. Okay, what is the definition of tangent? Okay, correct. So then we replace this with sine over cosine. Okay, so we'd use a trig identity to replace it. Now, if we want to find the derivative of that, we have a rule for it that we learned this chapter, because now that you've created a numerator and denominator, what rule can you go to? You can use the quotient rule, exactly, which is what we're going to do. So then this becomes not d dx anymore, because we're using the quotient rule to evaluate it. And so then I've got, all right, I've got my quotient rule set up. And so this would start with cosine of x, and then followed with another cosine of x. So the derivative of the bottom times the derivative of the top minus the top times the derivative of the bottom. And then the bottom is cosine x quantity squared. And then we follow the math and we let the rest of the math work itself out. So we're going to end up with cosine squared. It's just cosine times cosine. And then followed by what? What comes next? Is it addition or subtraction? It's addition. I've got a negative subtracting by a negative. So I have Sine squared x positive all over cosine of x quantity squared. And now we've seen this a couple times. Okay, my numerator is 1 over cosine x quantity squared. And the definition of trig identity for that, okay, we've seen this already, that the reciprocal, when you have cosine in the denominator, is the same as secant of x quantity squared, which you can also write as secant squared x. Those two things are the same. So how would you prove cotangent's derivative? Okay, any ideas? Yeah, go ahead.
You would use the same quotient rule, but it'd be cosine x over sine x
Uh-huh.
instead.
And guess what? It's one of your homework problems. All right, so you do that for homework. Okay, but it's not as bad as, you don't have to use, once you've proven sine and cosine's derivative using Newton, there's no other way to prove those. Once you have sine and cosine, then you can use the sine and cosine with any of the other derivatives, quotient rule, product rule, any of that. How would you do the derivative of secant? Yeah, what do you have to replace secant with first before you could do it as a quotient rule? 1 over cosine, and then you do the quotient rule to that. Okay, so it's always the quotient rule to prove the other derivatives. You start with an identity, and you finish with an identity. So we see identity in two places. We start with an identity here. Then you do the quotient rule. And then you end with an identity at the end based on what fraction you end up with. Okay? All right. Now we can do just a series of questions on practicing derivatives. So find the second derivative if y starts out as sine of x plus cosecant of x. So we've got to find the second derivative, which means we first need to find the first derivative. So let's lead this out with y prime. And it's just term by term. Okay, Leela, you want to do the first part? What's the derivative of sine? Cosine, good job. All right, so cosine of x plus, all right, we'll just kind of work our way down the row. Okay, Brandon, the derivative of cosecant x. And you can look back, it's okay, because we don't have that quite stored in our brain yet.
Negative.
Okay, it's negative, all right, so I'm going to, okay, it's negative.
Times
Cosecant x times cotangent x, okay, great. So that is the first derivative. Now we need to get to the second derivative, all right? So Sean, you're gonna keep going down your row, okay? Derivative of cosine.
Negative sine x.
Okay, minus, all right, Matthew?
Negative cosecant times tangent.
Okay, I heard you say times. If this is
We're using, we gotta use the rule, right?
what rule?
The product rule?
Yes, okay, so as part of this, because now this has become a multiplication problem, I need the multiplication rule, the product rule. So I'm going to need to set myself up with the product rule, but I also, because this is a subtraction, am going to need an extra set of parentheses around the outside because it is subtraction. If it was addition, I would not need that. But because this is a subtraction problem, I am going to need it. Okay, so you want to work from left to right and fill those in?
Okay.
What would we start with?
Cotangent.
All right, just start with cotangent of x. Okay, good. And now the derivative of cosecant.
Is negative cosecant times cotangent.
Okay, I'm going to just double up. I didn't give myself enough space. So negative cosecant x times cotangent x. So I'll clean that up in a little bit. Okay, you've got the hardest part, so keep going.
Okay, and then plus cosecant x.
Cosecant x, okay.
And then the derivative of cotangent, which is negative cosecant squared x.
All right, great. All right, now we will clean this all up and we will remember that we need to distribute our negative all the way back. So this is going to give me negative sine of x as I lead, but when I distribute that negative, the first negative to the inside and I encounter another negative, then that becomes a positive. And I'm going to have cotangent squared, because there's two of them, times cosecant x, because there's just the one. And then again, when I distribute my negative and I encounter another negative, there's another positive there, and this results as cosecant cubed x. Now there is nothing common with any of that. There's nothing that I can factor out. There's nothing I could simplify. I'm really just kind of stuck with that the way it is. Okay. Okay, let's try another one. Okay, find the tangent line to blank. All right, Nathan Deere, what do we need to find any tangent line in any situation?
Point and a slope.
Great. We are going to need a point. We are going to need a derivative. And then we're going to need a slope. All right. So, Ian, we're going to work your row through this one because there's three things and there's three people in your row. All right, you want to find me the point first.
The point is pi over 4.
Okay, pi over 4, comma.
Roots. 2 over 2.
Okay, and whatever the secant of pi over 4 is. All right, so yes, I can hear your brain thinking that through. Okay, so that's pi over 4, comma, whatever the secant of pi over 4 is. So if your brain takes a minute to figure out what the secant of pi over 4 is, I want you to think about, before you know the secant of pi over 4, hopefully you know the cosine of pi over 4, because those two things go together. The cosine of pi over 4 is root 2 over 2. Because that's a 45-degree angle. And the secant of that would be the reciprocal. Okay, and so I would just say simplify that as 2 over rad 2. That's the most common way you're going to see that as the reciprocal value. All right, Isaac, you're on for finding the derivative of secant.
Secant x times tangent x.
Great, secant x times tangent x. All right, so Nathan, the ball's passed to you now. Your job is to find the slope.
On the slope.
Uh-huh.
So I just plug that in, right?
Plug that in, plug what that? Okay. So we're going to plug in pi over 4 and to both places. All right, so what is the secant of pi over 4?
Then you get root 2 times...
It's 2 over root 2.
yeah, that
It does reduce, yep, but it's more common you're going to see it like that.
and then you times it by 1.
Good, times by 1. So you'll see 2 over root 2 as our slope as well. Okay, great. All right, so David, way in the back, you can write our tangent line for us. Can you see from back there?
Yeah.
Okay.
Tangent line is, it's y minus 2 over square root 2 equals to, it's 2 over square root 2
Okay,
and x minus pi over 4.
good job. And you could just leave it like that. You don't have to simplify. All right, you may have heard Nathan say he reduced that, and it would be totally fine if you wanted to say that was reduced to root 2, because that is what it reduces to. And so that would be totally acceptable as well if you reduced it. Okay. But either way, it's fine. Okay. All right, last one. Okay, normal line. All right, so our normal line is going to take us through the same thing. We're going to have a point. We're going to have a derivative. We're going to have a slope. And then it will eventually come up with our normal line. Okay. All right, so Sam will work with through your row since David got you started last time. Let's find the point. Okay, so pi, comma, tan pi over pi. And what is tan pi over pi? Right, tan pi is 0, so it doesn't matter that it's over pi. My point is pi comma 0. All right, Andre, you're up for derivative.
Okay, you can only do the quotient rule.
I am. Okay.
Alright. X times secant squared x minus tan x times 1 all over x squared.
Okay. So now we have our derivative. And then, Luke, it's up to you to find the slope.
So you're gonna plug in pi for the x's.
Okay, so pi times the secant squared of pi minus the tangent of pi times 1 all over pi squared. All right, so now we just got to remember a couple things about trig, bless you. We need to know what the secant of pi is, and I think we already did what the tangent of pi is, so we should be able to simplify. So this is going to be pi times, all right, what is the secant of pi if you know what the cosine of pi is?
Cosine of pi is negative 1.
Cosine of pi is -1.
Secant is negative.
Also -1, but what am I doing with that -1? I'm squaring it because this is secant squared, so that would be -1 squared. And then minus the tangent of pi. We've already covered that is 0. Okay, all over pi quantity squared. All right, and what does that simplify to be?
Pi over pi squared.
Okay, and what is pi over pi squared?
1 over pi.
Good job. All right, awesome. All right, so now we have our slope. So then we're ready to do our final of writing the normal line. All right, so Noah will have you do that today. Okay, y minus 0 or just y. Great. Okay, awesome. And that's the normal line. All right, so that's pretty much what you're going to be taking through with your homework. You're going to be just practicing the rhythms of those derivatives using the other rules that you've already learned, the product rule, the quotient rule, some trig identities, and some values off the unit circle.